Hello everyone, today we will be solving the question find minimum in rotated sorted array. So the question has given us nums, okay, this array, and it is asking us to return the minimum element. So it says return the minimum element of this array. Now let's read this question carefully, right? It is saying the original array was like this. It is particularly sorted because it is mentioned in the question itself, and it was rotated. So like if it is rotated 4 times, 4 elements greater than these are present here, right? This is a very important thing to notice here. And you must write this algorithm that runs in big O of log n times. Hence we know the only algorithm that runs in this time is binary search. We have to search and we have to look for the minimum element of this array. Now can we see, like, we have this element here 3, which is smaller than 4, which is smaller than 5, and then suddenly all the numbers decreases, like 1 and 2, which are smaller than 3 itself. So can we say, like, we can see this pattern here, like this was 3, 4 and 5, and suddenly there is 1. Okay, we are trying to visualize here, please. So then we have 1, and then again our numbers are increasing like this. So the values increase like this, then suddenly there is a drop and the value increases again. So we know, like, this is the peak element. The number of elements increases, the value increases till here and then suddenly drops. So this is a point that we are trying to identify. We have to find this peak point, because to return the minimum element, we can see, the moment we find the peak, the next digit itself is the smallest value in the entire list, right? If this makes sense, I hope this makes sense. Let's see in this again. Like, we have this example here. We can see, like, the values are increasing, and 7 is the largest element present in this entire array, and then suddenly 0, the smallest minimum element. So we have to just figure out the peak element in this list. So let's start and try to code this. L is equals to 0, the left pointer which will be pointing towards 3, and then the right pointer with the length of nums minus 1. Right now, while the indentation is wrong here, so it's left less than equals to right. Now let's check out this third example. Here we can clearly see that the array is not rotated at all. The left pointer is actually already pointing towards the minimum element of this entire array, and 17 is pointing towards the biggest, because this is sorted in ascending order. It is already mentioned in the question. So first we will make a check for this. If the array is not rotated, we will just try to return the first element itself. So let's see. Here we will write it as answer is equals to the first element. We don't know yet, but if the array is not rotated, then the answer would be this only. So first let's create a check for this. If num of L is smaller than nums of right, here the nums of L 11 is smaller than the nums of right. So we will do is answer is equals to minimum of answer nums of L, because L will be pointing towards the smaller elements, and then we will break through this. Right now let's find the mid pointer M, which will be pointing towards the middle elements in the array, right? So for them we'll be writing as L minus y2. Now this, we write it like this instead of writing L plus r by 2, because in languages like Java or C++, this might give integer overflow problem. But in languages like Python, it is totally fine to write it like this as well. But to prevent from integer overflow, in languages like C++ and Java, we write it like this. Now again we will checking if our midpoint is pointing towards the most minimum answer. So we write it like n nums of m. Now the first we will be doing what? Like we'll see if we are on the left side of the array. Right, how do we know we are on the left side of the array? Because nums of L would be smaller than the nums of M. We rotated, no, so the largest element here 7, it is somewhere here, no, so we'll see nums of L is smaller than or equal to nums of M. Then right, we are on the left side. Now we know like it is sorted in ascending order. Okay, 5, 6, 7 or 4, 5, 6, 7 are already greater than 0, 1, 2. Now since they are rotated and they have moved to the earlier part, all the elements on the left side of the peak element are obviously greater elements, right? And we need to return minimum, so we just have to look on the right side. So we'll move our left pointer to m plus 1. Okay, it's a if sentence, if or else we'll converge, like we'll move our right pointer to left direction or the other side. So it will be m minus 1 and we have to return answer. Let's see if this works. Congratulations everyone, this is working fine. It is also working for unsorted arrays. Now let's try and submit this. No, first let's check out the time complexity. This is a very simple binary search thing and we are just returning answer. No extra data structure is being applied. So the time complexity here would be, now time complexity would be big of log n and with the base of 2. Why we write as base of 2? Because in binary search we are dividing our search space into 2 parts. If we were dividing it in 3, we would be writing as base 3n. Okay, so right now we can just write it as big of log n, and the space complexity would be, since we are not using any special data structure to store our answers, it's big O of 1. Okay, now let's try and submit this. Congratulations, the answer got accepted. Thank you.